You can just message or just ping in the chat. Okay, so we have seen architecture of the HDFS, and we know that there are some components in HDFS. Those components are like name node. Those are like a name node, and there is something called data node. There are some other nodes. We are going to see that. As of now, we have seen only name node and data node on client. So clients, there is nothing much to discuss about the client. So client can be any machine, right? So let's talk something about a name node, and we need to understand what is a name node first of all, and we will see what is a name node and what he will do. What is the roles and responsibility of the name node in the Hadoop cluster, or you can say HDFS architecture, and what is the data node, what is his roles and responsibilities, right? So what he will do there. So we need to understand those things. Okay, so first we'll start with the name node. Okay, so as we discussed before, name node is a master node. It's also a physical machine, guys. It is not a logical, it is a physical machine. It is a master node who maintains the system information, like I can say file system information. Who manages or maintains the file system, namespace. So many people might get confused with the namespace. The namespace is nothing but like how the folders are stored, how the you can say where what is the path of the specific file, or what is the directory, what is the file, no, the path, whatever you call that path is called namespace, right? This namespace in the form of inode. Okay, what is inode? Inode is an object which is represent some set of properties, like you can say it's a data structure. So inode is a data structure object where you can say like uh, it will be having what type of file it is, what is the type of it, like it is a directory or is a file, and it will be having a permissions, and it will be having something like when it has been created, right? So we have seen yesterday, and it will be having a block information, and it will be having a replication information. So all this information will be there in your inode, your inode. So what is your main role of the name node? The first or the important role of the name node is it manages the file system information. It manages the file system information. It manages namespace information in the form of namespace, and that namespace will be in the form of tree structure. What is a tree structure? So as we already discussed yesterday, that tree structure is like, say my data is there in slash data slash amazon slash some sample.txt. Now if I want to put this path into data structure, or if I want if you say I need to put into the namespace tree structure, the first slash represents the root directory. Under this root directory, like a C drive. If you take in Windows machines, because so many people are familiar with the Windows machine, it is like a C drive. Under the C drive, you'll be having so many directories. Like one of the directories, data directory. So you can have another directory called data2 directory. You can have a data3 directory. Under this data directory, I have something called Amazon. So not only Amazon, I can have eBay. I can have something called Walmart. I can have this kind of directories. Then where is my file is there? Inside the Amazon, I have a sample dot. So inside this Amazon, I have a sample.txt, whatever the file I have loaded. This path, right? This is maintaining the form of tree structure. Even your name node manages the file system namespace, or you can say file system information. File system information. What is the directory? What is the file? In the form of inodes, right? It's ideally represented in the form of inode, right? So inode is nothing but it's a data structure where you can yesterday I have shown you the what is inode. So where you can see the directory, and where you can see the under the directory what is the file, under that file how many blocks are there, when it has been created. So all what is the size, what is the replication, who is the owner, permissions, everything you can able to see over there. Okay, that is the it maintains the first role is manages manages namespace information. So because it is managing the namespace information, that is the reason we are calling it as a name node. Why we are calling as a name node? Because a name node is a physical machine which is a master machine who manages the namespace, that's why we are calling this as a name node. Is this point is clear to everyone? Quickly respond to. So this namespace information, the name node maintains in the form of two different files, guys. It will maintain in the form of two different files. So what are those files? What are those files? Let me quickly cut this because I don't want. Let me quickly remove this. Okay, so it maintains the file system information or a namespace information in the form of two different files. Two different files. What are they? One is some people call journal file, some people call edits, some people for edit log, some people will call log file. It's R. Okay, all are same, guys. A log file, whatever it is, that's the file one, which is the transactional log. It will maintain the transactional information. We will talk more about edit log. I will show you the edit log. You'll come to know what is edit log. And other file is image file, file system image file. What is this? We'll call it as a fs image. Some people will call it as a some people will call it as a image file. Some people they will call it as a image file. So this image file will be loaded into name node RAM. This is the file which is available in the name node RAM. This fs image contains the accurate data. Like accurate data means whatever we need. The data like what is the directory, what is the file, what is the folder, what is the block size, what is the replication, that information, how much space has been occupied, that information will be available in the fs image, right? That's why your name node always loads your fs image into its RAM memory. And these two files will be there in name node. These two files will be there name nodes local native directories or local native file system, which we call local disk. Name nodes local disk. Yesterday someone asked me why it has to load in the local disk. I think Raghu or someone asked me the same question, why it is maintaining in the local disk, why can't it be in HDFS? So the very simple reason here, the name node is a master. Okay, name node is a master. If whatever the transaction you do, the transaction will be keep updating into this file. The transaction will be keep updating into this file. When you keep updating this transaction information to this file, the file is getting updated, right? The file is getting updated, and the file is getting merged. That merging process is called checkpoint. If it is there in HDFS, if it's there in HDFS, if it is there in HDFS, the updation is not possible in this file. Updation is append is possible, updating the file is not possible. That's the one thing. And the second is if name node crashes, you cannot access your HDFS. You cannot access HDFS. If this file system information, if it is there in HDFS, to interact with the HDFS, you need a name node. To interact with the HDFS, you need a name node. If name node itself is crashes, from where you will get the metadata information? We cannot get the metadata information if the name node crashes, if your edits and FSMS stores in HDFS. if your edit and FS image stores in HDFS, let's assume that this is the case. If it is storing your edits and FS image in local HDFS, if it is Namenode crashes, you will lose complete data. You will lose complete data because you don't have a recovery from, because the Namenode itself is crashes. From where you will get the backup. So the backup purpose of this, the data of this edit transactions and FS image will be there in the Namenode memory or Namenode local disk. FS image will be keep loading into Namenode memory. So there is something called checkpointing. I'll tell you what is a checkpointing, when the checkpointing will happen. Okay, so is this clear, guys? So why Namenode maintaining edits and FS image? Why it is storing into local disk? Why is not storing into HDFS? Okay, so this, so here your Namenode is maintaining these two files. Your Namenode is maintaining these two files. And, as I said, FS image once again. Okay. Okay, so FS image is a file system information. FS image is file system image. You can call it as a file system image. What is that file system image? The exact information of your file, like inode, the inode information, the structure of your data, where you have loaded. That structure image will be there in FS image. That structure information will be loaded into Namenode RAM. Okay, so when it will be loaded into RAM, who is writing into FS image? So we need to understand that. So your Namenode has some functionality called checkpointing. Some people will call checkpointing, or some people will call merging. Okay, so when it will happen? See, now as I said, I have an edit file here. I have FS image. Both will be there in a Namenode. Whatever the transactions you are doing with your cluster, creating a directory, creating a file, loading a data, appending a data, removing a data, right? So whatever the transactions you are doing are changing the block size, changing the replication factor, whatever the operations you are doing, in HDFS, that each operation is called one transaction. Each operation will call one transaction. Each transaction will have a transaction ID. That information will go into your log file, edit file. So your edit file will be keep growing, because your edit log will be keep growing when you are doing so many transactions with your cluster. Then when the FS image will be created, when so now I'm talking about a single Namenode. I don't have any other Namenode. I'm talking about a solo single Namenode and data nodes. I don't have anything else. Okay, I'm talking about that. When this merge will happen, now it's keep writing into edits file. Now whenever Namenode restart, what it will do, the first task, what it will do, it will read your edit log. And transfers the valuable information to FS image. It means it will create a new FS image. What it is doing? It is creating a new FS image. It will see, you have a old FS image, right? And whatever the transaction you have done with this edit log, and it will merge with this, and it will create a new FS image. This new FS image, once your system is restarted, after restarting, this information will be loaded into Namenode RAM. the merge process, or whatever the raw transactions are there converting into FS image process is called checkpointing, called checkpointing, or you can say, some people say merge process. While doing this process, your name node will be in a safe mode. Your name node will be in safe mode. Okay, so let's talk about the process one more time. Let's talk about the process one more time. Your name node has a edit file. You have a FS image. You have a FS image file. Very first time, guys, very first time you have just to start up a cluster, your edits and FS image will be empty. Your edits and FS image will be empty. Okay, so as soon as you started doing some transactions, what are the transactions I have told you? When you started doing a transaction like creating file, loading data, creating directory, changing the block, or changing the replication factor through a command line for the specific that whole information will be keep putting into this. Then when name node restart, this file will be empty. When name node restart, this information will be merged with the FS image. Some people call merging, or some people call checkpointing. Some people call merging, or some people will call checkpointing. So what is happening here? That while it's merging, it will bring all the valuable information to the FS image. While doing this process, your cluster will not be available, but it will not be available for writing the data. It will not be available for writing the data, but it is available for reading the data. It means your cluster will go into safe mode. Try to understand, guys, this is very much important. What is the safe mode? When your name node restarted, your name node start doing a checkpointing process or merge process. The merge process, first it will read the your edit log, which is there in the name node memory, hard disk, and it will put into FS image, merge with the FS image. While doing this merge process, your name node started, but service is not yet started. Name node service is not yet started. It means it is not ready to write. Right? So while doing this process, your name node will be in the safe mode. Till it is complete its process, your name node will be in safe mode. That at the same time, your data nodes also will be keep sending. Guys, your data nodes will be keep sending, because your name node itself is gone down, but data nodes are not gone down. Data nodes will be there, right? Your name nodes are gone down. So the data nodes will be keep pinging to the name node, saying that hi, 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 like that. So while pinging, they will also keep sending the block report. In that block report, and it is merging the report, this will be matched and it will be loaded into the memory. While doing this process, it will be in safe mode. That is called safe mode. While doing this process, your name node will be in a safe mode. What is the frequency of checkpointing? Frequency of checkpointing means here, there is no, as of now I'm talking about a single name node. I don't have any other nodes. I'm talking about solo name node. I'm not talking about secondary name node. I'm not talking about other nodes. In this case, whenever your name node restart, that time only the checkpointing will happen. Whenever your name node restart, that time only the checkpointing will happen. If you have other configurations like a secondary name node or some other nodes, that will be changed. There are configuration for that. There are 3 configurations for that. I'll tell you what is those configurations. How many times merge happen in a day? How many times your name nodes restarts, those many times it will happen. Yes, there is a configuration for other nodes, secondary name node. If you bring other nodes like advanced nodes into your cluster, saying that secondary name node or checkpointing node or backup node, then there are configuration for those. But as of now, I'm showing you only a name node and data node, nothing else. In this case, how many times your machine restart, those many times the merge will happen in a day. I hope it's clear to you, Raghu. But this is not the final cluster, right? This is not the final design of the cluster. There are so many changes are there in the cluster. There are so many changes are the cluster. We will be discussing about those changes, each and everything. Okay. Now this process is called safe mode. Okay. Now let's say I didn't restart my cluster. I didn't restart my cluster for a long time. I didn't restart my cluster for long time. Let's assume that I didn't restart for 2 months. What will happen? Your edit log will become huge. Your edit log will become huge. Correct? When this edit log become huge, the merge process will take more time. The merge process will take more time. The merge process will take more time. So when the merge process takes more time, when the merge process takes more time, your cluster will not be available. Your cluster will be name node. It means you can only read the data, you cannot write the data. You can only read the data, you cannot write the data. The limitation 1. If it is in safe mode, what is the limitation 1? I'm talking about limitations of the name node, guys. Solo name node. I'm not talking about multiple name nodes. I'm not talking about alternative nodes. I'm not talking about backup nodes. I'm talking about solo name node. Okay. The limitation is taking long time to restart the services. Long time to start the services. Second, let's assume that I didn't restart for 2 months. What will happen? So it will be file up with this, but my image will be old image. This will be old image file. So this time the name node is crashed completely. There are chances I will lose complete data. If it is recoverable, yes, good and well and good. If it is not recoverable, complete machine itself is burnout. So if it's not recoverable, there are chances for data loss. There are chances for data loss. Right? Because your name node is a single point of failure. Your name node is a single point of failure. If you want to talk to your cluster, if you want to retrieve your data, you have to talk to name node. There is no alternative way. As of now, you have to talk to this name node only. You have to talk to this name node only. You don't have any alternative. So whatever the data is there in Hdfs and these data nodes, if you want to get the data, you have to talk to name node only. If name node itself is not available, you cannot, whatever the data you have loaded into the Hdfs cluster is lost. Right? To overcome these two limitations, there are something called secondary name node. There are some feature called secondary name node. There is an alternative for not alternative, overcoming this limitation. There is a mission called secondary name node, and after that there are so many evaluations. We will talk about each and everything. Is everyone clear about it?
Yes.
Raghu is asking, in multi-node environment, that you will only see now. Raghu, it is little early to ask that question. I will show you now. Do we need to restart name node daily or any limit for that? Okay, this is not the final cluster. The first one I want to bring to you guys, this is not the final cluster environment in the production. We never go with the production with a single name node, single data node. First thing. So that answers most of your questions. So this is not a final cluster. Still, there are so many things we need to do with the cluster. I'm going to show you feature by feature. So we don't need to restart the cluster every day, or we don't need to restart the name node every day. Okay, to do the checkpointing, we no need to restart. Okay, good. Now let's talk about anyway data node. About the data node, we know very well about the data node. We already talked about yesterday. So I'm just taking you guys to secondary name node now. So the FS image files are stored in RAM. What happens when the name node gets restarted? We know the RAM is valid. Correct. I said it is load into name node local memory, local disk. Then that file will be load into the name node RAM, and it will be there in name node hard disk. It will be there in the name node hard disk. It will be loaded into the name node RAM when it is functioning. Good question, Raghu. How it will come out from the safe mode? Ravi, you said it is safe mode is on. When it is safe mode is on, you can do only read. You cannot write or do write. So whenever the process is completed, the merge process is completed, the FS image is loaded into the RAM, and 80% of the data nodes are sent their report. 80% of 80% of the data nodes are send the report. At least one replica, guys. Like all the data nodes send their replica information to the name node. Then your name node will come automatically come out from the safe mode automatically. Your name node will come out from the safe mode automatically. That is configurable. How long it has to be in safe mode, how much, when it can bring it out from the safe mode. That is one automatically. There is one more thing called manually. We can also bring out name node from the safe mode to normal mode by executing some admin command. I'll show you that admin command later. Clear, Raghu? Okay, let's talk about how the secondary name node is going to solve this problem. The secondary name node is going to solve this problem. Now let me draw here. This is my name node. This is my secondary name node. This is very much important, guys. This is a very much important question, as well as we should know this thing. This is name node. This is secondary name node. This is secondary name node. Now when you are configuring your secondary name node, there are two configurations. There are two configurations. Those configurations are actually three configurations, guys. Okay, two configurations are checkpointing interval. One is checkpointing interval. One is hourly basis. One configuration I'm telling that checkpointing hourly basis. Another configuration is when it reaches to 1 million transactions. What is that 1 million transactions? When it will happen? Let's look at, guys, here. You keep talking to the name node. Your name node has edit file here. Your name node has an edit file here, and it has fs image. Your secondary name node role is, I'm talking about the pure secondary name node, guys. I'm not talking about anything else. There is something called checkpoint node. I'm not talking about that. I'm talking about pure secondary name node. The role of the secondary name node is it has to talk to name node every 1 hour, or whenever it reaches to 1 million transactions. Whenever it meets a 1 million transactions, who will be checking that whether it is a 1 hour, whether this condition is true or this condition is true? Who will be checking? There will be something called interval, checkpointing interval configuration. So it means three configurations. So whenever it meets 1 hour condition, it will go and talk to the name node, and it will take the edit log file, and it will take the fsms file, and it will do the merge process here or checkpointing process here. It will create a new fs image. It will create a new fs image, and whenever it is given this is given to this guy. So this edit file will not be make use for new transactions. Let's say this is transactions are happened till here. Now the transactions are started again. For these transactions, your name node will create a new fs image file. Sorry, edit log file. It will create a new edit log file. And whenever it meets the either of this condition, whenever it meets either of this condition, again your name node will talk to a secondary name node will talk to name node, and it will fetch this guy and merge with these two guys, and it will create a new fs image, and it will create a new fs image, and it will create a new fs image. So this process will be keep going on. Ravi, how it is solved the problem? I'll show you how it is solved the problem. Now let's say my mission I started my cluster at 8 o'clock. At 8 o'clock edits and fs image is empty. At 9 o'clock I have done some transactions. Till 9 I have edits and fs image. Edit and fs image. I have done some transactions. Your secondary name node, what it has done, it has taken and merged and it's created new fs image. And 10 o'clock, at 10 o'clock, again now one more checkpoint is happened. It is merged, edits and fs image is there. Latest fs image, latest transactional information, latest data information is there in this. Okay. Now at 10:45, at 10:45, my name node is dead. I'm taking about case 1, guys. I'm taking case 1. In the case 1, name node is completely dead. I cannot take any recovery. I cannot take any recovery. What will happen in this case? How much data we will lose, guys? How much data we will lose? We will lose only these 45 minutes of transactions, whatever you have done. So the before you have done already kept in the backup file. It's not backup. You already merged and keep the latest fs image. So only this of 45 minutes transactions, whatever you have done, you will lose that information only. That information only. Second case, completely dead. Okay, it's a completely dead case. Second case is just to name node restarted. Just to restarted. Just to restarted. It is just restarted. In this case, I need to do checkpointing thing, no? Your name node has to do checkpointing thing, before it was doing right. Before, when it does not have a secondary name node, it was doing right. Yes or no? So now, how much data I need to merge? Do I need to merge from the 8 o'clock, or I need to merge from only 10 o'clock? I need to merge from 10 o'clock only. Why? Because this already has merged by secondary name node. Your assistant, that assistant guy is already merged, right? And he already merged and he created latest fs image here. Okay, you need to merge only these off node transactions. You need to merge only these off node transactions, 45 minutes transactions, right? So that we will done by whom? Your name node will do, and he will update the fs image and will do that. So now what we have done with the secondary name node, we have what we have done, we have reduced data loss, and we have reduced the starting of the name node. We have reduced loss of the data, and we have reduced at the same time, we have reduced uh, what you call starting or restart time of your name node. Is this point is clear to everyone? How data is in sync in both primary and secondary name node? Okay, it will not in a sync. It will not in a sync. It will just fetch the edit log information to the secondary name node, and it will fetch the fs image, and it will merge and create the latest fs image. The latest fs image is always with the secondary name node only. Here we are going to see one more limitation with this guy, secondary name node. What is the limitation of the secondary name node? The secondary name node is keeping himself his fs image. Secondary name node is there with whom? FS image there with whom? Secondary name node. Limitation 1. Still we have a time consuming. I mean, still it is there. Restart time. We have reduced, but still restart time is there. Name node restart time. Taking some time to restart. And still data loss is there, but we have reduced the amount of the data loss, but still data loss is there, right? So what is the limitation? Why it is a limitation? The updated FS image there with the name node. What is the problem? The problem is whenever a name node restarted at 10:45, what he has to do? He has to merge with these edits. He has to he has to merge with edits because that edit file is there with him only. He can take from him. He can take from his hard disk. To get the updated FS image, we need to ask this guy, hey, give me latest updated FS image because I need to merge. Then he has to take FS image from secondary name node. Then he has to merge and he has to keep with him. He has to merge and he has to keep with him. Right? So that's the reason. So because explicitly your name node is requesting for FS image from the secondary name node at the time of restart, when it restart. Raghu, is that your doubt is clear? How data is in sync in both the primary data will not be in a sync. So the data will be fetched from the name node. It is fetching by your secondary name node. Your secondary name node is taking the data from data means it's not actual data. It is a metadata. It is a metadata information, namespace information. It is fetching from the name node to secondary name node and it's merging process happening internally. Any doubts, guys, till here? Okay, now still we have limitations. Still we have limitations with the secondary name node. Then how can I solve the problem? So there is still limitations are there with the secondary name node. So how can you solve that? We have something called oh, sorry, please. We have something called checkpointing node. There is something called checkpoint node. So I have explained about a secondary name node. Now I'm going to explain about a checkpointing node. Checkpoint node. Guys, they have poorly named as a secondary name node. Actually, that is not actually secondary name node, right? Secondary means primary, secondary means what? If primary goes down, secondary will work. Correct. So they have poorly named as a secondary name node. So they realized it. Oh, we have given wrong name to this, and they have made it as a checkpoint node. So they replaced the secondary name node with the replace. It is not addition, replace. They have replaced secondary name node with a checkpoint node. So how disaster recovery can be performed? Here disaster means if both the nodes are dead, we don't need to do any work. We can shut down our cluster, we can sit in the home. If disaster happen, the cluster is shut down. Anyway, by default it will go shut it down. So we can sit at home aram se, we can take off. Apart from name node restart, is there any case that name node will go to the safe mode automatically? There is another case, Priyanka. There is another case when your name node find so many corrupted blocks in the cluster, so much of imbalancing thing. That time your name node will go in a safe mode. So that use case I'll show you.
Yeah, imbalancing means under replica and over replica cases
Yes.
we can consider, right?
Yes.
Yeah.
In name node, every time same edit file gets updated, no such Sanchari Ganguly, it will every time it will create a new edit file after it's given to this. That's why I have shown you here. If you see here, that's why I have given, it is given and it's created new. It's a new edit file. Okay. Now let's talk about checkpointing functionality. What is a checkpointing functionality? As similar as secondary name node. Nothing changes. As similar as secondary name node. Only feature change is as soon as it's updated, as soon as this merge process is done, it will give back to the name node. I don't want, I mean, he'll keep on copy with him. Okay. He will just give to name node. And here also he'll give to next name node. Now 8 o'clock my transaction, 9 o'clock everything is merged, 10 o'clock everything is merged up to date, 10:45 done, down, 10:45 down. So I'm not taking the dead case, in this case restart case. So in this restart case what I will do, I no need to explicitly request to give me fs image. I no need to ask a secondary name node or checkpoint node to give me fs image. So what you will do, fs image and edit log both is available with you only. Edits and fs image both is available with the name node only. You can just fetch and you can just merge it and update the things. He will just fetch and he will update. I mean, he will do that. Is that clear, everyone, about the checkpointing node? Any doubt? Okay. Okay. So I'll repeat one more time. So your checkpoint functionality is as similar as our secondary name node. The only new feature is it has upload back feature. It has something called upload back to name node feature. The latest updated fs image is there, right? That updated fs image will be uploaded back to the name node. Now your name node will be having edit file as well as updated fs image. It will be having updated fs image. So when it is restarted, when it has to do a checkpointing functionality, I mean merging functionality, so edit and fs image both is available with him only, with the name node only. Then he can easily merge it. Then easily he can merge it. Any doubt? Please go ahead if you have any doubt.
Ravi, Anand here. One question.
Go ahead, Anand.
Uh, Actually, we could find there are multiple copies of FS image in the folder, right?
This is because of this. It is creating so many FS images, right? Every merge
I
it is
mean, is
creating
in
one
every
FS.
restart,
Yes, it's
every restart we get one FS image
yeah,
copy.
yeah.
Okay, fine. Thanks.
So every checkpointing, every merge it is creating one new FS image file, right? Any other doubts, guys?
Veera, I have one question.
Yeah, go ahead, Mallikarjun.
Yeah, actually, when compared to data nodes, the name nodes occupies the less memory. Then why we are not maintaining the replication factor 2 or 3?
So how will you maintain the replication factor for the name node? Name node, the data is loading into local file system. Do you have anything like in your local file system, like your Linux box or your Windows? Do you have anything called replication factor?
No, we don't have that
So
one.
here also same. The name node is loading the edits and FS image into its own hard disk in local file system, not in Hdfs.
It's completely apart from the Hadoop, right? I mean,
Apart from HDFS, apart from HDFS,
okay, apart from
yes,
okay, that's why I'm maintaining only one copy.
yes.
Yes,
Why
yes,
why
I
it is
got it.
not why it is not putting in HDFS? I already explained before.
Yes, I got it. Yes.
Any doubts, guys? Okay, so Priyanka, after merging, new FS image will be created. What about old FS image? It will be it will be there. It will be there with the name node.
Yeah, but
See,
so many will be
actually,
there, right?
see,
All of these images.
yeah, see here, Priyanka, there are two cases. Okay, there are some commands for that as well. So every time, right? So whenever the merges happen, the functionality will update the existing FS image only. Okay, the functionality, one functionality is already creating a new FS image means it will be updating the existing FS image. Okay, it will be creating, it is updating the existing FS image. It is not actually creating a new one. Okay, and as per your question, how come, as per before one guy asked me the same question, how come there are
Yeah,
multiple FS images? How come we have a multiple FS image in that? So you can also do a merging manually, or you can also create FS image manually using some command is there. Okay, so while creating that, your FS image is getting created a copy. While
okay.
execute that command, the duplicate copy is getting, or not duplicate copy, and you are creating one FS image file. So that's why in the most of the environment, when you see, it will be having only one FS image, and you will be having so many edit logs, so many edit logs. But yesterday when I shown my environment, you guys observed two FS images, because there is one command when I was executing, creating some save point. I forgot the command. That time it's created one FS image. That's why in my environment two FS images are there.
Okay. In production environment, ideally only one FS image will be there, right?
Yes, only one FS image will be, FS image file will be there. That will be, I mean, there are multiple. Again, we have something called high availability. We have something called federation. There are some other things out there,
Yeah.
right? So they will
Yes.
be maintaining only one FS image will be there. Suppose if anyone explicitly they want to take a backup, or they want to keep it in the same location, they can create manually with the multiple FS images. As part of the process, it will be only one FS image. It will be updating to existing FS image. I know that here conflicting my statements. Okay, so before one guy asked me why it is two FS images are there. So I said it every time it's creating a new FS image. So that's what it has, a different functionalities in different versions. So in the latest Hadoop 2 version, what we are doing, what I am seeing here, it is always updating with the existing FS image, always existing in FS image. Okay, so if you another why it is created multiple FSMS, because I have executed one of the command there, one command there. I'll show you that command. I forgot exact the command, but I think save. I'll see that and I'll explain you. And which node the three configurations will be present? What three configurations? Yeah, the three configurations should be there in all the machines. Configurations will be same for all the machines, guys. The configuration should be same in the master. The configuration should be same in the client. The configuration should be same in the one child. I mean slave.
Veera, I'm asking about these three configurations,
Yes,
like
yes,
after every 1 hour and 1 million,
yep. These
it will get the
configurations.
edit file, right?
Yes,
Yeah, these configurations.
these configurations will be with all the machines. See, the setup and
Okay.
configurations will be same with all the machines. The replication factor, the block size, whatever you're doing a configuration, the configuration is the same with all the machines.
Okay, it means actually in the name node, once it reaches 1 hour, so it will automatically send that edit file to the secondary node.
Actually, that functionality will be done by the secondary name node.
Yeah, that's what.
Yeah.
After 1 hour, secondary name node will request for the edit file to
Yes,
the name
yes, yes,
node, right?
yes.
So if that is the case,
Hmm.
so how the secondary node will come to know that it reaches 1 million transactions?
So that's what I'm
Because
trying to
that
say. No,
transaction happen.
that's what I hear, right? The see here, when you see there is one more configuration, third configuration, it's called fs fs.name node dot check interval. Okay, it will be checking whether it's
Okay.
made to 1 hour, or the transactions are done 1 million transactions, because even your name node also will be Your name node also has the same configuration, and it also will be keeping an alert or alarm in the name node saying that when I have reached 1 million transactions, right?
Yeah, yeah.
So
Okay.
that case it can give a request to a secondary name node to take. It's not like one way, okay? It's not like, I'll come and pull, right? Your name node also can request to take, or your secondary name node also can take, can request for the data.
Yeah, yeah. Okay. I wanted to understand that only, whether
Yep.
name node will send it to a secondary node, or secondary node will request to name node.
No, the
So I wanted to
different
understand.
scenarios, right? The 1 million when it reaches 1 million transactions, just your it will send the request to the secondary name node.
Okay, okay. All right, all right. Fine.
Any other doubts, guys? I think no doubt everyone is uh, good with it. Okay, let me see any chat messages. Okay, so that's it for today, guys. So we will discuss there are some limitations at the checkpoint also, right? The limitations are still you have a data loss, still you have some time it's taking for restart the name node. How we can overcome those limitations which are there with the secondary name node checkpoint node. We will be doing we'll be discussing that tomorrow. Yeah. Yeah. Thank you, guys. Thanks for your time. Have a great evening.